Today I want to do a video about NFX Glue. As I have received a few emails, people asking, or some people are confused what glue does. The NFX Glue is the part of the NFX Unistech framework that allows us to glue remote endpoints, contracts, and instances between the nodes, glue them together in the distributed system. So for those of you who are familiar with what WCF is, Windows Communication Foundation, for us, Glue completely replaces the WCF. Again, that is for us because it provides all of the features that we need, and quite honestly, it provides 99% of the features that 99% of the applications need when the applications are written in the Unistech concept. So the concept of glue is very similar to what a concept of Windows Communication Foundation is in terms of like message passing. It is a message-oriented framework where you exchange messages between the contract endpoints. So let's give it a try here. Let's look how it works. So let me run a test server, and then let me run a test. Here I have some dummy Windows application where I can dispatch test calls. Those are not unit tests, but more of a manual integration tests. It is right here. Okay, so let's first of all, how Glue operates. It has a concept of binding, just like Windows Communication Foundation does. It is a similar concept. So binding basically tells you what kind of protocol and what kind of message exchange pattern is going to be used between the endpoints. So if we go and we select a sync binding, the sync binding is the binding based on TCP/IP blocking socket, just regular socket programming. Okay. And so now what I'm going to do, let's say, first of all, let's do a few echoes. So the server responds with those echoes, as you can see here. Okay, so let's do this. Let's do 10 callers, 10 parallel reactor, 10 parallel threads, 1,000 calls each thread. And let's run it. And that gives me 34,000 calls a second. So this application calls the server, which is running right here, okay, in this window, in the same machine. This is the name of the Sextot is the name of my 6-core machine. Okay, so let's do this. Let's add the number of workers, and let's increase the load to 8,000 calls per thread reactor. And let's try doing this, and we're gonna get a result in a second. Although I may lose my video, I think my video recording is actually killing the performance because it introduces a lot of context switching. So on this machine, let me do this. I forgot to do this as well, and I'll explain in a second what this does. On this machine, I usually get about 120,000 calls a second. Okay, and I got 94,000 calls right now. Let's try to repeat the test. Like I said, the video recording really kills the performance. Okay, so I get around 100,000 calls right now. My computer is doing something else. But what happens is this test right here does a two-way call. That is, okay, here we go, 100,000 calls. So if I turn off the video recording, I would average 125,000 calls a second. This is a two-way call. That is, I call the server, I pass it some arguments, then the server does some simple arithmetic and returns me back a string that says you have supplied this and here is the result. Okay, so there is not much business logic that is executed on the server, but if you were to try to replicate the similar test using Windows Communication Foundation on this server, on this computer, you'd been lucky if you achieve somewhere around 60,000 calls a second. Okay, so this definitely, I mean, that is in the best case with WCF. Now, if I do a one-way call, here's I have a button here that does a one-way call. That is, it gives a call to another host, and it gives it some payload, but it doesn't expect any return from that call. Okay, so let's put, something like 700,000 calls, because this is going to be very fast. And what we're going to see now, again, my video recording really kills me. I usually, let's try it one more time. I usually average in this computer somewhere around 300,000 calls. Now, interesting observation here. Remember, I run the client and the server on the same machine. I have a different machine here. I'll do another time. I'll do a video where I'm going to run the client on that machine. So I can easily achieve 400,000 calls, one-way calls between these two machines. Okay, and if you are interested in what kind of machine this is just a regular Core i7. It does have 6 cores with hyper-threading, and it does have lots of RAM, but RAM is not really of that much of an importance here, other than it does affect your garbage collector performance. And of course, I'm running in 64-bit mode here, but like I said, the context switching. Another thing is, for those of you who use Skype really affects the performance, I think, because it does a lot of threads and a lot of context switching. It really skews your performance benchmarking if you do it like this. Of course, this is not a proper way to benchmark it. I mean, but it gives you a pretty adequate picture of what your code can do. Okay, so another thing is, so let's do 5,000 calls to the business logic that is going to return a record set of 8 fields, like first name, last name, city, state, zip, and every record set will have 10 rows in it. Okay, so I do 5,000 calls, two-way calls. So let's say I execute a query on my server, and the server returns me 5,000 times 5,000 data sets. Every data set is 10 records long. Every record has 8 fields in it. So let's put 250 records in this call and see how this guy is going to perform. And of course, the performance significantly degrades because we have just pumped 5,000 times 250 records. Okay, and keep in mind that's a lot of information. That is a lot of information. And like I said, have you been using WCF, you would have received somewhere, in the best case, 500 calls a second, not 3,000 calls a second. Okay, so this performs very well. Again, you need to do a lot of tests on the different threading, different throttling scenarios using different technologies if you really want to understand how it works. I find that a lot of developers, a lot of companies, and many people never do any tests. If someone gets like 10 calls a second, they're satisfied. This is very slow, and you would be really surprised what you can achieve with the good written efficient software on the modern hardware. So pumping tens of thousands of business objects a second without causing much stress is not a big deal if your system is written correctly. Okay, so I mean, here you have it. So we are achieving a very, very good performance here. Um, Unfortunately, the video recorder really skews it, but you'll have to run this test. If you get this code, you can run this test on your computer and see the results for yourself. Now, another thing to keep in mind: if you have an Intel SpeedStep technology, it will really lower your frequency on the CPU. If you have a desktop processor, that really kills your performance. So what I usually do, and I haven't done it right now, but what I usually do if I run real, precise performance tests, you have to change the power setting in your control panel to performance. So your CPU stays high. Your CPU stays somewhere around 3 gigahertz instead of going to 1 gigahertz. You see how it jumps back and forth? So if your tests, to run an accurate test, you need to run this test for like 45 minutes and then average out. You cannot run your tests short like this because your performance is going to jump all over the place, primarily because of those things like video recording, Skype, like I said, and this thing here. The SpeedStep technology really affects it as well. But anyhow, so here is that's a test rig that you can use just for manual, what I call manual testing. Okay, so if you ask me a question, how did we achieve such a performance? So we're like 3, 4, 5 times faster than Windows Communication Foundation at the very least. And most of the time, we're like 8 times faster than WCF. So let's first start from the serializer. And I have another test here that shows you that shows us the what we've done with the serialization. The Glue framework is based on bindings, like I said, and protocols. And you can do HTTP, JSON, and all of that stuff. But those things are extremely inefficient. The most efficient thing, of course, is the binary data transmission. And I know a lot of people say it's not REST friendly. It doesn't have to be REST friendly. The glue is the technology to connect internal peers on your internal distributed system. Let me ask you a question. The motherboard, the processor, talks to your RAM on the motherboard. It uses internal, so to speak, motherboard, North Bridge or South Bridge protocol, whatever it's called. And you cannot really connect to the motherboard externally. If you want to connect externally, you need to put a controller like SATA controller or Ethernet controller. There is a reason for this design. The reason is you need to achieve as much performance and throughput as you physically could through the motherboard, okay, on the motherboard. Here, the concept is the same. The glue is primarily a technology for connecting on the motherboard, so to speak, okay? So if you have a server, another server, and another server, and you need to talk, they need to talk to each other and pump millions of messages. So you'd better use glue, because glue allows you to work on the higher level, contracts and methods. We'll get to this in a second, but let's first talk about the serializer. The glue has a binding, a family of bindings called native bindings. Okay, those are binding native to glue, and they're implemented right here. There are 2 of them. The first one is called Mpx, which stands for multiplexing binding. Okay, so it is a bidirectional socket. It sends information and it doesn't block the socket channel until the result comes back for the 2-way calls. It multiplexes one socket for multiple calls, okay? Another binding is called sync binding, which is very similar to Mpx, only it is a synchronous, 100% blocking synchronous socket. For those of you who are familiar with what Berkeley blocking, socket is, that's what sync binding does. And you may say, oh, why would we want to have 2? Well, the reason there are different scenarios, and of course the best performance you can get for a large transfers is through the synchronous binding, because synchronous model of programming, contrary to what many people think these days, is way more efficient than asynchronous for special kinds of operations. We will get to this in a second, okay? So the idea here is that both of these bindings, they use something called Slim Serializer, which are based on the Slim Serializer implemented right here. The Slim Serializer is a highly optimized, dynamically compiling expression tree serializer, expression tree based serializer that allows you to serialize complex graphs, including cyclical, acyclical, network-like, self-referencing with transitive references, all kinds of crazy object graphs. So if you're familiar with Google protocol buffers and other serialization frameworks like Avro and other, Apache Avro and Apache Thrift, or Thrift is Apache, yeah, I believe Thrift is Apache, but those frameworks usually impose a limit, a requirement that the graphs of objects that you push through the wire, they have to be acyclical. They have to look like trees, not like true graphs with transitive or direct cycles. Now, we do not impose this limit because our serializer is a binary serializer and it perfectly handles any kind of data, okay? Now, so let's look at the test here. So here, there's 3 buttons, and I know this looks like crap. I know that this is not a good-looking test, but believe me, it does its job. So this is Slim, serialize, deserialize, Microsoft binary formatter, serialize, deserialize, and Microsoft data contract, serialize, deserialize, okay? So Slim, binary formatter, and data contract serializer. This is what WCF is mostly based on in most of the cases, okay, how people use it. So I'm going to push this button, and the first time it will compile it will be very slow, okay, because it will compile the code, it will compile the expression trees to serialize those objects, okay. So you see, I achieved. Now again, this was a slow path, the first one. Okay, let me click this button. So remember, 10,000 transactions a second, and I have serialized 25,000 times some payload. We'll look at the payload in a second. Let me click this button second time, and the second time my performance is going to get better because now I get 11,000. And again, the problem here is with this Intel speed step technology that you have to click a few times to get the proper picture. So I get somewhere in the vicinity of 11,000, 12.4, 11.9, so somewhere around 12, let's say 11.5. Let's be on the safe side of things, okay? 11,000, at least 11,000 records a second or objects a second. Okay, now let's try to run Microsoft binary formatter. For the same payload, it's exactly the same payload. I populate the list with some crap, and then I serialize it with 3 different serializers. Okay, so we received 1.9, so almost 2,000. Let's say 2,000 transactions a second. Now remember, ours was 11,000 at least, and this gives us 2. Okay, let's try it one more time. Okay, so it still gives us around 2. And we go data contract serializer. One would think that it would be way faster than binary formatter because it almost, okay, let's call it a second time. It almost gives you 4,000 objects a second binary format. I mean, data contract serializer. But remember, it is absolutely nonsensical to try to what the hell is this? Some window just popped up. It is absolutely nonsensical to try to just benchmark one-way operation. You need to compare it with the deserialization on the other side, because that would give you the speed of the full circuit, what I call the full circuit of communication. So we click this button that will deserialize 25,000 times. So the speed of the channel is determined by the slowest link in the channel. Okay, I think this is self-evident, but many people forget it. My friend One of my friends does a lot of Node.js development, and he uses Apache Bench or another program that just opens a socket, sends a request, and closes the socket. I say, you're not testing anything. You need to parse the JSON result. You need to test the whole thing, how it works, because we're not comparing apples to apples. I mean, the TCP socket test on the Windows machine or a Linux machine can easily, if you send bytes and you don't parse them, can easily give you 500,000 records a second. But what does this test prove? Nothing. I want you to keep in mind that we test here business objects and business operations with rules, with security checks, with routing, with a lot of other things that we do, and that's the speed that we achieve, okay? So please do not compare this to ZeroMQ. ZeroMQ is a very low-level framework. It doesn't do anything that I'm talking about here. ZeroMQ does not provide you with security permission checks. ZeroMQ does not provide you with polymorphic contracts. It doesn't have a concept of a contract. You just send a piece of a byte array in ZeroMQ. We do a different thing here with this approach. So the data contract serializer actually cannot handle more than, and I'm rounding this up. You see, 1,400 requests a second, okay? Now, this test, one more time, this is a single-threaded test. If we go with the multi-threaded test, the performance difference with the Slim serializer is going to get even bigger, okay? So the Slim serializer is on average, and then pay attention. The Microsoft data contract creates 20,000 bytes of payload. Now, if I go with the Slim serializer, I only get 4,000 bytes of payload. The same payload, and I get 11,000 transactions, more than 11,000 transactions a second. If I click this a few times, if I turn off the video compression, the Microsoft stack really, becomes maybe 1-2% faster. The Slim serializer may go all the way up to 14,000 transactions a second. Okay, so that's how it works. So the serializer is phenomenally fast, and the reason for it uses type registry. It tries to compress space. It uses variable bit encoding for integers. It also does not call activator create instance. It compiles dynamic lambda functions that give you call the constructor, the default constructor on object instances. And our serializer understands struct, read-only, fields, properties, all of that stuff, whereas Microsoft serializers, they break. There are a lot of cases where they cannot handle, the data contract serializer cannot handle polymorphic extensions and circular references. It just crashes sometimes. So that's a separate topic, but that gives you some background why Glue is so fast. So let's go ahead and look at the server program, okay? Where is my server program? I think it's somewhere here. Okay, test server. Here is the program. Let's look at the program. There is nothing here. It spawns the application container. This is my main method, static program main. It creates the application container, and then it blocks here with a read line. Okay, and then the only thing it does, it dumps the endpoints. You see this, I go through my glued endpoints and servers and just print the servers to the console. That's all I do. And then I block. Okay, so, but where is the server? I don't understand where my server is. So let's go to the config file, and it will become evident that the server is very simple. So if we look at the config file in the glue section, first of all, there are a lot of stuff here that I can tweak. Tons of stuff. I can do message tracing. I can specify, I lost count, around 18 TCP parameters, like receive buffer window, sizes, timeouts, all of that stuff. But basically what you do here, you do a binding, you give it a name, okay, and then you give it a type that handles this binding, okay, and so this name becomes a synonym with the with the type of the binding that they use and all those parameters here, okay? So when you type a URL that looks like, or what we call node here, that looks like sync : / blah, blah, blah. So I can do sync 1, sync 2, and just have a different parameters here, okay? I can also inject inspectors on the server and the client side. So for the server transport, I change some. I can also turn on the statistics measurements on the endpoints, on the contracts, on the messages, on the methods, on the arguments. This is crazy how much stuff you can do with this. Okay, so an Improv binding would allow you to communicate via glue within your process. It is just a fake binding, so to speak, like for inter-class communication via glue protocol, mostly used for testing, but you can use it for other things. Okay, so here is an Mpx binding. You just give it a type and assembly where the binding is implemented. And here is the list of my servers. I give it the name of the server. It's like a name of the endpoint, just a logical name. That's the address. So I want to listen on all addresses on this port. Now again, this syntax right here depends on the binding. I can create a binding that would listen on a USB port or a COM port or anything I want. Okay, so how this works, it first parses out the name of the binding, okay? Then it tries to find this binding by name here, so let's say sync binding, okay, it takes this binding, and then the rest of this URL, but this is not really a URL in terms of HTTP. It's just a what we call node, okay? And it is similar to URL on the web. It parses the rest of this URL depending on the binding parses it, okay? So you can use any kind of crazy syntaxes here, okay? All right, so and then you specify what servers you want to expose on these addresses, okay? So that's pretty cool. Server inspectors, I don't have any. Client inspectors, I don't have any. And then, so this is it. This is my server. So where is the server implementation is right here, I think. The joke server is iJoke contract, okay? So first what I did, I created this joke contract, okay? And what I do here is that I have a bunch of methods. Here is my, by the way, here is my, remember that method I told you about that takes some parameters and returns you a payload. So here, I have those methods here, and then I just decorate them, the interface with the glued attribute. Okay, it tells it that this contract should be glued. So the glue compiler now generates the stub for me for calling the methods on. I mean, this is pretty regular stuff. And then I can put permissions. I can put authentication support on the contract, on the method level. So here I do some ad hoc permission, which is basically a string. So whoever calls it has to have test permission space flight and echo permission within this namespace, and has to have view and change access level. Okay, and this guy has also to have a sultan permission, whatever this means. Okay, this is some joke from some Russian movie. If I were a sultan, I'd have 3 wives or something like that. Anyway, this is an example of a typed imperative permission. You can create a permission in your code and just put it like this. It's an attribute. Permission is a form of an attribute that you can protect this method with. And here is how you decorate this as a one-way attribute, saying that this has a void, it doesn't return anything. Now, even if it's a void, this could have been a two-way permission. Why? Because, or two-way method, rather. All methods are two-way by default, unless you say it's a one-way method. Why? The reason for it is that, you know, the two-way call with a void returns you a receipt back without an exception, so you know that your method worked correctly and didn't cause any exception. Okay, so that's my first contract here. Now I can also put headers. Here's an example of a header. A header is just another class that you can attach or struct No. It has to be a class. I beg your pardon. It cannot be a struct. It's a class that has to extend this class here that doesn't do nothing. It's just a marker, so to speak. And you can attach it as a out of band, so to speak, data. So let's say you want to put a filter around this method here. You can do that, and you can pass it extra parameters, and they're not going to be a part of this contract, but they're going to be passed via headers, okay? So that's understandable. Now, important thing here, look at these two guys. So they have identical signatures, but they have different names, and this guy has an Args marshalling attribute, okay, that Glue supports, and it gives it a type of the argument marshaller. So if we look here, I have a class here that extends a request message, and it has a type safe signature for the method. Check this out. So what this allows me to do, this allows me to avoid boxing. So you know, like in WCF, you would pass those messages via an object. Everything is an object. Now, this is where a lot of slowness comes from. You cannot box primitive types. I mean, you can, but it is very, very slow. Okay? Why is it very slow? Because it is. That's how boxing works, okay? And it is not slow if you're talking about 10, 20,000 calls a second. It doesn't, who cares? It is fast enough. If you're talking about 200,000 calls a second on a production server, this becomes a necessity, okay? So you can optimize your message signature. So instead of packing those primitive arguments as an object array, it will use this typed request message, and it will generate code on the fly, a type safe code that will avoid any kind of boxing, okay? So I guess that becomes clear, okay? Now, here is an example of the joke calculator that calculates 2 plus 2 and stuff. What's interesting about it is that this guy is stateful. And notice that I have this definition not on the implementer, but on the interface. Well, that is because it is a part of the contract, really. I need to tell, I can, if I wanted to, decorate certain messages or methods as constructors and destructors. Okay? So these are parts of my protocol. So I'm saying that I have to activate this calculator. I have to call a constructor first and call the init method. Now, this is stateful server programming I'm talking about here. And a lot of people say, oh, everything has to be stateless. Bullshit. Absolutely not. It has to be stateless if you are a purist or read a lot of, modern books about, how everything has to be stateless, blah, 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 blah. There are very many cases where stateful programming allows us to achieve orders of magnitude faster operation via the connected IP channels. If you want to pump 25 million records between databases in different cyber centers, you have to use stateful contracts. I don't want to pass with every call where every byte costs me money that I pay for. I don't want to pass 25 kilobytes of crap with every call. I want to pass only 10 bytes of payload for every record from my database. And I even want to compress it. So the stateful programming allows me to apply a special kind of business data compression. And I'm going to make a different video about it some other time. So, and this is actually, so here is the deal. Stateful programming is not very scalable if you don't know what the hell you're doing. It is a killer. You create a stateful system, your performance is going to be crap if you do not know what you're doing. If you purposely create a software that is stateful for some specific operations, like system programming, replication of data between peers and nodes of a highly distributed hash table or a database, you have 300 nodes to replicate this to, then this is going to save your day, and this will make your system 100 times faster had it not been stateful. Okay, so this just, you have to take my word for it, and we are not open sourcing our Om cluster framework yet, but when we will, you will be able to see how the stateful programming is used, how is it utilized, okay? What else do I have here? Okay, so here's my server. Here's my server. Here's my thread. Oh, that's another interesting attribute. It says that the implementation is thread safe. So that means that for the stateful servers, it will not lock. Glue runtime is not going to lock my method calls. Because I say I'm thread safe, okay, so I have to lock whatever if I have to. I have to handle that shit myself. Okay, so the joke calculator, in it has a value. Okay, see that? It has a value right here. It remembers it between the calls. If you time out, your state is going to be destroyed. If your server restarts, your state is going to be preserved. Because in NFX, we have a concept of volatile address space in your application. I think I talked about it in some other video. For the volatile object store, the state is kept in the object store here, okay? But at any rate, even if your server restarts, your instances are not going to die. Okay, so I hope that makes sense to you. What else do we have? So for the test server, I have joke calculator server is here, and my joke server is here. So I do some work. Remember that this crappy loop that generates crap simple person row and returns it, and then it emulates the latency as well if you want it to. What else do we have? And here are my, remember when we averaged like 110 calls a second, 110,000 calls a second? That's my business logic. It just does to string and adds them all up, okay? So it creates string mutations. I purposely didn't use string builder just to utilize more, make more allocations here, okay? So that's how it works. And like I said, you can put security permissions right on your server or on your contract, okay? So that's how it works. Let's look at there is somewhere here should be an assembly. Oh, here, business logic right here. So this is where my joke contract is, okay? This is where my client is. Here's my client. This code has been automatically generated. This code has been automatically generated by a Glue compiler tool, okay? The Glue compiler tool is accessible, Glue compiler ? It's very simple. You give it an assembly and it scans for files for contracts, and it creates the, either compiles an assembly for you or creates the source code, okay? For your call stubs. And it is very simple. And you can also extend it. So here is the contract. Joke calculator client. Client endpoint iJoke calculator. It implements the same interface. And it does a lot of optimizations that deal with, you see, as much of the reflection crap it can do, it does it in the constructor instead of doing it in every call. And then every method has a synchronous call, which is basically a trampoline into asynchronous call. Asynchronous call is basically, it does a request message, then it does a dispatch call with this request message, and it returns you a call slot. Now, what is a call slot? A call slot is like a mailbox, is spiritless, it doesn't have any thread, a spiritless mailbox that you get back from the runtime of Glue, and you can pull it. Now, people are like asking me, why don't you use as await async and all of that stuff? Now, first of all, the system was created before await async existed. Secondarily, I have no plans of creating await async. Those methods of working with Glue are very inefficient. They're superficially handy and efficient, but they are internally, when you compare it to this, they're way less efficient than call slot. Call slot is a very tight class that uses a spin lock to deliver the payload, or uses the what is it called, the monitor pulse and stuff. It doesn't have any threads in it, and in many cases you already have a thread. You don't want to deal with any thread coordination. Now, as far as async await in C#, async await, they're very bulky. They need tasks. Okay, tasks are objects. They take RAM, and the way how they work, they consume RAM with. So if you need to allocate 200,000 calls, okay, you'd better not allocate extra objects that 200,000 extra objects that will induce the pressure on the garbage collector. Now, what I'm telling you right now has been verified and tested. This is not just something that I'm just pulling it out of somewhere because I think. It's not my opinion. It is the way things are. The more objects you allocate per every call, the slower the whole thing gets, because eventually your garbage collector would need to clean that crap up. Okay, the call slot can be easily converted into a task. It has a property called as task. Okay, but most of the time you don't need it. You don't need to introduce extra allocations in your calling chain. So the call slot, that is a very it is a lower level object than a task. Okay, so and in many cases when you have to execute hundreds of thousands of calls a second, this works way faster than dealing with tasks, async, await, and all of that stuff. That is extremely inefficient. You are not going to see this inefficiency unless you go into hundreds of thousands of calls a second. Okay, so that explains you why it works this way. If you go to joke contract, okay, so joke contract client, this is the guy who has many methods here. Okay, and I believe one of those methods does the custom Args marshalling. Remember we talked about here. Simple work. Here is the trampoline that uses the custom Args marshalling with the type safe array instead of object array, byte array, or object array. You see how those, without Args marshalling, I have to pass an object array with boxed copies for those primitives. And that really sucks because it does boxing, it does extra allocation. With the Args marshalling, I don't have to do it because I can pack it in the type safe manner. And believe me, this gives you, on the very tight schedules, that gives you another 25-30% speed performance increase. Okay, especially if you run your operations for a long time. Okay, you will see at the end of the day that your solution became 55% faster just because you switched to Args marshalling. That is, if you gauge your solution within like 2 days, you will see that difference because the garbage collector has to do less work. Okay, you're not going to see instant gratification for it, only like 2-3%. But if you run it for a long time, you will. What else do we have here? Oh, here's my dummy permission. Okay. So that explains how this works. And so we talked about Glue. We talked about the serializer, why it is so fast. Now, the Slim serializer does not support versioning of objects. Okay, we have a different serializer called Portable Object Document Serializer, which does support, but it is way slower. It is going to be somewhere up to par with Microsoft Binary Formatter. Okay, so why would I use, if I run a software of the same version on 3, 4, 5 boxes, which is the case in 99% of cases, for me at least, I don't need object versioning, okay? I don't use Slim Serializer to persist objects on disk. I only use them to transform my memory and do marshalling between the parties, okay? So that's what I use Slim Serializer for. And as far as performance counters, NFX Glue comes with a huge instrumentation stack. These are the performance counter engages that you can get. Here are your events, okay? And you can see how many client bytes sent, server bytes sent, messages declined, load factors, a lot of stuff. How many times you had a message that could not be parsed, corrupted messages. How many times you get over max message size? We have a protection from like buffer overflows. It is all built in here. Okay. Do I have SSL built in? No, I don't need it. Absolutely, I do not. Because SSL is an extremely slow thing. Again, remember, does the processor use SSL between the CPU chip and your memory chip? No, it does not. It has a data bus, which is engraved right in your motherboard. If a hacker took a probe and connected an oscilloscope or something to your motherboard, he could have probably deciphered, got those meanders or whatever, the pulses from the conductor on the motherboard, and uncovered. He could have uncovered the sensitive information. That's true. So close your computer, okay? Don't let the hacker physically into your cyber center or something like this. If you need security, that's fine. You can cipher your traffic. You can write your own binding. I never had a need for it. The Glue protocol, the Glue system, can be used on the internet via an HTTP, but why would you do that? It doesn't make any sense. Most of the time, you use Glue for internal, we use it only for internal communication in our cluster system. So that's what Glue is for. And therefore, it is way faster than WCF. It does not need to have a lot of things that WCF has, like legacy, WC extensions, and MTOM, and all of that old stuff that Microsoft, they did a great job with WCF, but it became so complex and so broad in its scope, yet it is very, slow for things like that. And it just doesn't have any ways to speed it up, okay? You do have a class here called call reactor where you can put a lot of call slots and get events. So call reactor turns an array of call slots into a series of events, callbacks. I used it once. I don't have much use for it because most of the time I already have a thread or some other way of spirit that visits my call slots, so to speak. Okay, I don't need to introduce extra threads. What else? A call slot gives you just a way to, like I said, to get your results back. Here is an internal state. There is a task completion source that is only lazily allocated if you convert a call slot into a task. Okay, but other than that, don't call as task here. Here is the property as task that allows you to obtain a call slot instance as a task that returns a call slot. And it can time out as well. The task always completes. If it times out, it completes with a call slot that has a result set to timed out. Okay, and a lot of stuff here. A lot of stuff here. Very pliable, very flexible system. However, it is very, very terse. There is not much code here. As far as the implementation on the server, it has a dispatcher, it has a handler, and all of that stuff. And you can use different threading models, and you can use do a lot of crazy stuff here. The tools, the Glue compiler is right here, is a part of the framework. What I showed you from the command line, that was just a client front-end driving program for this class. The inspectors I told you about, you can inject inspectors. The NOP glue is the kind of glue that does nothing, okay? Self-explanatory. The instrumentation, you did see a lot of events and gauges, and by default it's all turned off. You can turn it on and see how it works. Who talks to who, okay? And another interesting feature here, if we go to bindings, this will give you just an overview of how many properties we support for closing transports, idling transports, existing acquisition timeout, count wait threshold, max count, existing acquisition timeout, milliseconds. Okay, so how this works? It tries to impose a limit for the number of open channels to the outbound host when you make a call. Okay, so as long as you're below the threshold, it will keep allocating transports if it can't find an existing transport which is not busy right now. Okay, if it is above that threshold, then it will go and allocate the new transport unless you reach another threshold level. And all of those things are actually right here. Okay, those are your defaults. And those this accounting is performed per outgoing peer. So let's say you need to communicate with 5,000 servers. You can say that because you have so many servers, you can say do not allow to open more than 3 channels at a time per server. Okay, so you can throttle the glue connections, and those client transports are going to get automatically closed, and server endpoints will also get automatically closed when they are idle for X number of minutes or seconds, whatever. All of that is very configurable here. The statistics of calls is subject for exponential moving average filter that you can also set up here. So that is, if you're not familiar what a moving average filter is, that is, let's say you have some latency, you call some method and it gives you like 10 milliseconds, 10 milliseconds, 10 milliseconds, and all of a sudden you get an outlier, 200 milliseconds. Then you're back to 10 milliseconds, 9 milliseconds, 11 milliseconds, 10 milliseconds. So the filter would rectify this one single spike. It is going to absorb it. Okay, just like you're a coil on your car, a shock absorber. It will absorb that heat. Okay, why is it necessary? Well, it is necessary because in the cluster environment, we automatically measure some SLAs for some services, and we can say if my time is my SLA gets violated, I can start getting some panic, signals, email messages to sysadmin or whatnot. But I don't want to panic just because one time the garbage collector engaged and everything became slower for one single call. I don't want to get panic. So that's what exponential moving average filter, which is built into the binding actually, right here, is very simple. You can also do a lot of things like dumping of your messages. I think we can look here at the... I hope I haven't obliterated. Okay, message dump folder here. So I can browse those binary messages here, or whatever. Request response messages. Okay. That's how they look. So here you have some headers, signatures, some cross checks, and you get the name of the contract that you are calling, and you get some cross check signatures, and then you get some slim data here, which is highly optimized. So again, if you compare this 88 bytes, compare this to a WCF message, which is, even if you use XML binary formatter the Microsoft provides, you're going to get, for the same message, you're going to get around 3 kilobytes, and I get 88 bytes. That's why I can pump so much data through a network that I pay for the bandwidth between my European cyber center and the cyber center in the United States. I don't want to pay a gazillion dollars just because I pump crap, because my serialization framework is crap. Okay, and this data is in transit. I don't need to version it. If I change my version, I'm going to stop the process, change the version in both places, and run it. It's a bridge, okay? But because of that bridge, I can save quite a few bucks every month on my traffic. Okay, here is a response from the server. Remember that call with Args marshalling that I showed you? So here is the response. Okay, it is very optimized. 88 bytes, that is. Okay, so, and you can dynamically, of course, turn this message dumping dynamically, and you can also specify the dump format, binary, decimal, hexadecimal, printable, if you want to do it as a text. The operation flow, like I said, a binding can be synchronous or asynchronous binding. That is, it's a duplex binding or a single way binding that blocks. All of that stuff, this configuration, the tons of stuff here. Okay, but most of that stuff you don't need any knowledge or understanding how it works, because most of the stuff, like I showed you, you just put in the config file like this. You create a contract, you create a server, you create a client trampoline to call it, and I think I didn't show you how you call it, how you call the client. So let's look at this. Where's my manual test with that WinForms test? There should be a glue form here somewhere. Okay, here. So let's say I call this for the simple work. So this is how I, and it does a lot of stuff here for the test. But you just call you just make it like this. You create a contract. You create a client. Joe contract client node. Node is just a string with the name of that. Remember that sync :/sex port blah blah blah. So the dispatch timeout, reserve transport. That is, I want to reserve the transport and the channel for my instance. So no one else gets. I bind the channel to this instance, which is going to yield me another 3-4% performance boost, because my runtime wouldn't need to match the client with the transport every time. It will match it just once, and then we'll keep it matched and keep it reserved. Of course, if you don't deallocate it, you're going to waste your channel. Okay, but you have to understand what you do, with this, if you want to achieve this level of performance. And then you just call the method. Okay, you call the method like this, and let's look at the simpler. Okay, this echo button. What does it do? Where is it? Okay. Client, Joe contract client. Here's how I can add a header, by the way. Check this out. Authentication header, ID, password, credentials. This is the stupidest, simplest credentials to use with the security. They're not secure at all, though, the plain text credentials. But hey, they do their job in 99% of test cases, at least. For simple test cases, if you want to test security. So I just put text box ID, password here, and then what I'm going to do, I will either call unsecure echo or secure echo, depending on my checkmark result, and it will return me what the server has echoed back, because this returns me a string per my contract. Remember, this guy implements a contract, Joe contract, and the Joe contract has echo. Where is my echo? Unsecure echo, the take string and return string. Unsecure echo doesn't have any permissions on it, and that's it. That's what Glue does. And I think I've covered most of the things, let me see here, that I wanted to cover for today. And next time I'm going to talk about how we call the web services from the with NFX Wave, because I don't use Glue for making web services. Web services is for web. Mostly, that's where they're called web services. And Glue is mostly for communication within the Cyber Center. So I hope that was informative and answered many questions that people have asked me in the past few weeks. Thank you.